Hi everyone. We're going to talk about chemical interferences in flame AA in this video, and there are three types. I thought this diagram would be helpful as we go over these chemical interferences. The first one is the formation of non-volatile salts. So you may remember that example I've given you in a couple of the previous videos, how if your sample matrix is high in sulfate, it may form in your solution and you may be able to nebulize it, but once you reach the flame, especially if you're limited to an air acetylene flame, you will not be able to create these gaseous iron atoms. So that would be the non-volatile salt formation. Another chemical interference is an ionization interference. So imagine that you nebulized your sample and you've created free, let's say, gaseous sodium atoms. Well, sodium is easily ionized to the sodium ion, and that could decrease your signal. That would be an ionization interference. And sometimes molecules can also form. So an example would be for calcium. You've nebulized it, you've volatilized it, you've got this gaseous calcium atom, but it can form an oxide in the flame that'll decrease your signal. So in this video, we're going to focus on non-volatile salt formation. And let me again ask you to recall how, again, in the presence of high sulfate in a sample matrix, so this could be in your sample, you may be able to nebulize it, but in an air acetylene flame, you do not produce these gaseous iron atoms. Another analyte for which this happens is calcium. So calcium, in the presence of high sulfate, suffers from the same problem. You may be able to nebulize it, but again, that air acetylene flame is not hot enough to produce gaseous calcium atoms. Phosphate can also have the same effect on both calcium and iron. So if you are unable to use a hotter flame, so if you cannot use a hotter flame, or if you can't use a plasma, you'll have to modify the sample. You'll have to add something to the sample to disrupt this complex. And there are two things that you could do. You could add a releasing agent. It's something that binds to the sulfate more tightly than calcium, and thereby you can release the calcium. So you can add a releasing agent, and this would bind to the sulfate in this case. And you know what works well as a releasing agent is lanthanum. So if we add lanthanum, and let's imagine that we're trying to do this experiment where we're trying to measure calcium in the presence of sulfate. So we add it to our sample containing that non-volatile calcium sulfate complex. Lanthanum will bind to the sulfate, releasing the calcium, which then can be atomized. So no longer do you have this in your sample, you've got these free calcium ions that can be atomized. Another so-called matrix modifier that you might want to use would be a protective agent or a protecting agent, which binds to the calcium, protecting it from the sulfate. And can you think of a ligand that binds to calcium? I sure hope so. I hope EDTA popped into your mind. You can add EDTA to your samples, again containing this non-volatile salt. That EDTA will bind to the calcium, protecting it from the sulfate, and this can be atomized. That air acetylene flame is hot enough to break down the EDTA and produce gaseous calcium atoms in the flame. So I think that's it for how we can deal with non-volatile salts. Hope you enjoyed the video and thanks for listening.